Now this one's going to be a little bit more difficult, but we're going to walk through it. So let's try this one together. And here I'm going to try to get rid of my y's. And the reason I'm going to try to get rid of my y's is because if we look, they already have opposite signs in terms of the coefficients. And whenever I'm doing elimination, I'm really trying to get opposite coefficients. So if one's positive and one's negative, that's already a good start. Really, if you can avoid having to multiply by a negative, that's best because that's where we tend to make mistakes. We tend to not distribute the negative correctly. So I'm going to try to get rid of just my y's here. So I'm going to rewrite them. And to get rid of the y on top, I'm going to have to multiply that by 3. And then I'm going to multiply the bottom one by 2. And that way I'll have negative 6y in the top equation and positive 6y in the bottom. If you wanted to, you could get rid of x by multiplying the bottom one by 3 or negative 3 and the top one by that 8 or negative 8 if you had a positive 3. And you'd be able to do that. But I'm going to get rid of the y's because it's going to be a little bit easier. So that gives me 9x minus 6y is equal to 3. And then 16x plus 6y is equal to 4. And now I'm just going to add these up just like normal. So adding these up gives me 25x equals 7, which means that x is equal to 7/25. And I know in a lot of these problems, we've looked at just kind of positive whole integers for our answers, but you're definitely going to have some on the test, and otherwise that are going to be fractional, so it's good for you to see them. So now I have to plug it in and try to figure out what my y value is. So I have 3 over 1 times 7/25 minus 2y equals 1, which gives me 21 over 25. And I'm going to be subtracting that from both sides. So I'm going to rewrite this 1 as 25 over 25. That way I have that common denominator of 25, which will allow me to subtract. So I subtract 21 over 25 from both sides. And I get negative 2y equals 4/25. From here, I'm just going to be dividing by negative 2, which essentially I'm taking multiplying that by negative 1/2, which means that y is equal to negative 2/25. So now we think that our answer is 7/25 comma negative 2/25. And if you have an answer like that, especially on the test, I highly, highly recommend that you go through and make sure to check your answer. Because especially with a fractional answer, you want to make sure that you get it right. So since we use this left equation, we can't use that to check because that's how we got our y value. So I use my right equation and I say 8 times 7/25, 8 over 1 times 7/25, plus 3 over 1 times negative 2/25, and we want that to be equal to 2. That's our goal here. So 56/25 minus 6/25 will leave us with 50/25, which is equal to 2. So that's our final answer. And again, it might not be obvious, and sometimes you're going to have whole numbers, sometimes you're going to have fractional, so you always want to check. All right, you try this one on your own, pause the video, and come back when you're done. You should have gotten the answer 2 comma negative 3. And if you got that, skip ahead. If not, let's check it out. So here it doesn't really matter what I get rid of. I can either get rid of my x's or my y's. I'm going to choose to get rid of my y's here just because. It doesn't really matter which one you do. So again, here I have to try to figure out if I'm going to get rid of my y's, then I need to have those opposite coefficients. So I'm going to multiply this top one by 4 and the bottom one by negative 3. That way I'll have 12y on top and negative 12y on the bottom. And it doesn't matter, that could be a negative 4 and this a positive 3, but you have to have one positive and one negative because they have the same signs, and we need them to have opposite signs in order for us to eliminate them. So that's going to give me 20x plus 12y equals 4. And that's just me distributing the 4 into that top equation. The bottom one gives me 9x minus 12y is equal to 18. And I kind of did this on purpose so that way I'd have more kind of positive numbers to deal with. And that gives me 22 equals 11x because my y's get eliminated. So I divide both sides by 11 and x equals 2. From there, plug it in and go. So 3 times 2 plus 4y is equal to negative 6. 6 plus 4y is equal to negative 6. Subtract 6, and this is where you might have made a mistake and had a different y, and you would have gotten 4y. Some of you might have written 0 here, but it's really negative 12. Divide both sides by 4. Y equals negative 3. And if this were a different problem that I didn't already have the answer to, I would always double check to make sure that my work is correct, but I know it is, so we move on. Last one. Try this one on your own. P's and Q's. So you have P is going to be kind of your X value here. Q is going to be your Y value here. Pause the video and come back when you're done. This is a bit of a trickier question. We haven't seen a problem like this, but this would actually be infinite solutions. If you got that right, congratulations, you did good things. So stop the video here and continue working on. If not, stick around and I'll explain. So I'm going to try to, oops, that's plus Q. I have to get rid of one of them. So let's say I want to get rid of my P's. If I want to get rid of my P's, really all I have to do is multiply one of these, that bottom equation in particular, by negative 2. You could have also multiplied the top equation by negative 1/2, but we don't really have to. So that top equation rewritten gives us 6P plus 2Q is equal to 20. And if I multiply this by negative 2, I would have gotten negative 6P plus negative 2Q is equal to negative 20. Adding these up gives me 0 is equal to 0. And because 0 is always equal to 0, that's always a true statement, that means that we have infinite solutions. So if you are able to get rid of both of your equations and still have that true statement, that means infinite solutions. We could kind of already have a hint of that because if we were to just have this equation, we would get 3P plus Q equals 10, which is the exact same thing as that first equation. So if you can identify that the two equations are going to be the exact same, that means that they're going to be intersecting an infinite amount of times if we were to graph them. So every single point that works on the one line is also going to be a solution for the other. All right, and this would, if you had no solutions here, you would realize that you would have a non-true statement. So that would be something like 0 is equal to 5. So if you had something that's a not true statement, that means that you're going to have no solutions, and that would be two parallel lines. So they would have the same slope, but different y-intercepts. All right, thank you for watching, and have a great day.